Hello students, last time we have taken the graphical representation of the motion in which we have taken the distance versus time graph, velocity versus time graph and acceleration versus time graph. Now today we are taking the equation of motion. So whenever we are taking the object moving on the straight line with the uniform accelerated motion, then the three quantity velocity, acceleration and the distance which is related with the time is expressed in terms of the set of the equation. So this is known as the equation of motion. So here first of all we are taking the graph of the velocity versus time. Here we are taking the accelerated motion. Accelerated motion of object. The object is moving on the straight path, straight line with the accelerated motion, and here we are taking the uniform accelerated motion in which the velocity change in the equal interval of time. The delta v is changed in the equal interval of time. So delta v change equal. The delta v is changed equally in the equal time interval, which is known as the uniform accelerated motion. We have taken the graph like this also for the v versus t. We have taken this type of the graph. Now today we are taking the equation of motion from the velocity versus time graph. So now we are taking the velocity versus time graph. Here the time is given on the x-axis. Here is the time. Let us take this is the t equal to 0 time. At the t equal to 0 time, we are taking the initial velocity u. So already at the initial time, the object is moving with some velocity, that is the initial velocity. This is the initial velocity. Here as the time is going, then suppose at the time t, object's velocity we are taking as a v. So here in the uniform accelerated motion, the graph v will get like this. Here is the v at the t time. So now here from the graphical representation we get the set of the equation, that is the equation of motion. So here we draw the perpendicular line from u to this line, and we give the points name. Let us take this is the A, here is the B, C, D, this is the O, and here is the E. Now see here we are taking some notations. First of all, this AB from the graph, AB is equal to EC, and it is V minus U. So it is the change in velocity. Whereas time interval is t minus 0 or the O. DO is equal to BC is equal to t minus 0, that is the t, it is the time interval. We have three equations of motion. Now, first of all, we are taking the slope or the definition of the acceleration. According to the definition of the acceleration, A is given by change of the velocity upon time interval, v minus u upon t minus 0, v minus u upon t. First equation. From this we get A into t is equal to v minus u, and from this we can write v is equal to u plus at. So this is the first equation of motion. So we can say that the slope of the graph is also gives the equation of motion v equal to u plus at. Slope of v versus t gives acceleration. So we can say the slope is equal to AB upon BC is equal to A, and it is v minus u upon t minus 0. This implies we get first equation of the motion. Now second, we are taking the distance covered by the object in the time interval t. Distance. So how we can find out the distance from the v versus t graph? If we calculate the total area covered by the v versus t graph, then we get the distance, because the area value of the area in the v versus t graph, that gives the distance covered by the object in the given time interval. So here distance is given by area of, let us take the triangle ABC plus rectangle CBDO. Area of the rectangle CBDO. So we can say that the distance S is equal to area of the triangle ABC 1 by 2 base into height. So 1 by 2 BC into AB plus area of the rectangle CBDO. We are taking this and this area CBDO. Its area is given by BD into DO. That means the S is given by 1 upon 2. BC is equal to time t. AB is equal to change of the velocity v minus u. BD, the BD is u, initial velocity, and the DO is again time t. Now from the equation 1, v minus u is equal to at. Now this equation we are using in this equation of the S. So S is equal to 1 upon 2 t. Instead of v, we are writing the at. Instead of the v minus u, a into t plus ut. So S is given by ut plus 1 by 2 at square. So in this way we get the second equation of motion from the equation of the distance, that distance is given by the area of the ABC plus area of the rectangle CBDO in the v versus t graph in uniform accelerated motion. So we get the s is equal to distance is equal to ut plus 1 by 2 at square. This is the second equation of motion. Second equation of motion. Now from the equation of motion second, s is equal to 1 by 2 into t v minus u plus ut. Here we can simplify this equation and we get the another equation. By simplify we get s is equal to vt upon 2. We are taking this equation. S is equal to vt by 2 minus ut upon 2 plus ut. So ut minus ut by 2, it is the ut by 2 plus vt upon 2. So in general s is written as v plus u upon 2 into time t. Let us, so this is the equation 2a, and here we are taking the equation of the t from the first equation, that t is equal to v minus u upon a. So s is equal to v plus u upon 2 into v minus u upon a. So v plus u into v minus u is equal to v square minus u square upon 2a. So in general we can write this equation s is equal to v square minus u square upon 2a. That means v square minus u square is equal to 2as. This is the equation number 3. Other equation also we can write s is equal to v plus u upon 2 into t. So it is the average speed into time. So in this condition we can write average speed is equal to s upon t, and average speed is given by v plus u upon 2. As here the motion is the uniform motion, we have taken the average of the speed, that is the v plus u upon 2, but it is only in the case of the uniform motion. So these are the equation of motion. First, v equal to u plus at. Second, s is equal to ut plus 1 by 2 at square. These two equations we obtained from the graph, and third equation we obtained from the equation s is equal to ut plus 1 by 2 at square. So these three equations are known as the equation of the motion. Another topic we are taking, that is the uniform circular motion. What is the uniform circular motion? When the object is performing motion on the circular path with the constant speed and with the changing velocity, this type of the motion is known as a uniform circular motion, and this uniform circular motion is actually accelerated motion, because here the velocity is changing. Velocity is changed at each point. So this is known as the uniform circular motion. In this uniform circular motion, if you are taking any point and if you draw the tangent at the point, then the direction of the tangent shows the direction of the velocity. Here also the direction of the velocity is in the direction of the tangent. So here at each point the velocity is going to change but the value of the velocity is not changed, and the value of the velocity is the speed, and the speed is constant speed. So here we are taking the radius of the circular path is r, and if we are taking the one revolution, so to cover one revolution path, circular path, object's distance is given by circumference of circular path or the circle. So we can say it is the 2 pi r. The s is equal to 2 pi r. So we can start from this point, the motion from this point, and again the particle reach at the same point in the circular path. Then it cover the 2 pi r distance. So the speed is given by v is equal to distance upon time 2 pi r upon time t. The particle takes the time t to complete the one revolution. So in this way we get the speed v is equal to 2 pi r upon t. Here the acceleration we are getting in this motion as the velocity is changing. So this is the uniform circular motion and it is the accelerated motion. Remember, this motion is not the uniform velocity, because here the velocity is changing, velocity is not constant, but the speed is constant. The value of the speed is remain same, but the direction is going to change at each point. So we can take the example of the uniform circular motion, that the satellite is revolving around the earth in the circular path. First example, any cyclist traveling on the circular path, then its motion is also known as the uniform circular motion. If you bound the stone with a thread and if you revolve it in the circular path with the constant speed, then it is known as the uniform circular motion. So now this is the last topic of the chapter, uniform circular motion. Now solve these examples given in the exercise.